Okay, the image here shows the letter D shown in the font called Arial, which is a nice clean looking font with easy to analyze shapes. The letter D in Arial font consists of a large black tall rectangle here, and then not a circle but an ellipse with another ellipse inside of that. And what I'd like to do is figure out the equation of the outermost ellipse. We can do this by doing transformations of a circle. So I'm just going to draw the rough outline of the outer ellipse of that shape. And it's not exact. This is not meant to be super precise. But we'll get an idea of it. Okay, so look at that ellipse in red. And I'd like to compare that with this original circle, which we've been calling, and we will continue to call, the unit circle. The unit circle has a radius 1, and it has center at 0, 0. And what we want to do is transform our unit circle into the red ellipse. Well, the unit circle equation is x squared plus y squared equals 1. 1 because r squared would be 1 squared, which is 1. So what we want to do is think about what transformations occur from the blue curve to give the red curve. Well, the blue curve has a diameter, or a width, of 2 units, and it has a height, or a diameter, of 2. But the red curve is not a circle, so it's got we call it the minor axis, or a width of 8, approximately 8. It has a major axis, or a height, of approximately 10. So if you think about those widths and heights and the stretches that we're going to need to apply to the blue curve to yield the red curve, we will need a horizontal stretch by factor 4. We'll need a vertical stretch by factor 5. That'll get us the necessary width and height of the relation. But we'll also then need to translate the curve so it's no longer centered at the origin. We need to translate it so that it's centered here. That's the point 4, 5. So then we'll need to do a translation right 4 units and up 5 units. Okay, so do we know how to do that? We sure do. We have the way of figuring out the translation rule. And the translation rule for that would be horizontal stretch, factor 4, so 4 times x, and then right 4, so that means add 4. And we need a vertical stretch by factor 5, so that's going to be 5y, and then up 5 means add 5. Okay, so that's the translation rule that will change the blue curve into the red curve. What we will need to do is put subscripts on these variables, and then we'll say that that resulting point is going to be renamed as x2, comma y2. And when we look at that translation rule, that tells us that 4x1 plus 4 is the same as x2, and it tells us that 5y1 plus 5 is equal to y2. And when we take those and we rearrange those, we can rewrite those equations as x1 is equal to x2 subtract 4 over 4 and y1 is equal to y2 minus 5 over 5. So these are the equations that we're going to substitute in to our original parent equation. Our original parent equation is up here, and we'll put subscripts on the on the x and the y, meaning that's the original or the parent. So when we make substitutions, into that equation, which was x1 squared plus y1 squared equals 1, then we're going to have this thing squared and we're going to have that thing squared. So that will give us x2 minus 4 over 4 squared plus y2 minus 5 over 5 squared equals 1. If we drop the subscripts, because we don't need them anymore, we know that this is the image, and we know that this one was the original. So we'll drop those subscripts because they just get in the way. Then our equation is x minus 4 on 4 squared plus y minus 5 on 5 squared equals 1. I think it would be nice to simplify that equation a little bit. So that is going to be x squared minus 8x plus 16 over 16, and we'll have y squared minus 10y plus 25 over 25 equals 1. Now we don't like those denominators of 16 and 25, and if you just notice that 16 multiplied by 25 is equal to 400, then what we can do to get rid of those denominators is multiply both sides of the equation by the same thing, 400. And what that'll do is clear out the denominators. So when we multiply into the brackets, we're going to have 400 canceling with 16, and 400 divided by 16 is 25. So we'll have 25 multiplied by the first numerator, and then the 400 will multiply against the second fraction, and 425 cancel, giving 16. And 400 on the other side. Okay, so we got rid of our denominators, which were kind of nasty. Multiplying into the brackets now with distributive property will give us 25x squared minus 200x plus 400. And then in the next bracket, we'll get 16y squared minus 160y plus another 400 equals 400. Let's move everything onto the left-hand side. So we're going to have 25x squared, and it's customary to write the highest degree terms at the beginning. So we'll now move our 16y squared up to the front, right after the x squared term. And then we put our linear terms with exponent 1 on the variable. And then we put our numbers. We have 400 and 400 is 800 minus 400 is going to be plus 400 equals 0. So this is the equation of the ellipse. If we put that equation into GeoGebra, it automatically moves the 400 to the other side. And if I turn that graph on, it looks exactly like what we'd hoped for. It's an ellipse that has a minor axis reaching from 0 to 8 on the x scale, and a major axis, the longer axis, running from 0 up to 10 on the y scale. The center of the ellipse is 4, 5, just what we wanted to have. So that is our letter D.